Hey, I'm Brandon Graysley. I'm a high school math teacher. Let's continue practicing substituting and evaluating. We've got a few expressions, and I've got some values for the variables to be substituted. So here I have the formula for the area of a rectangle, length times width. Here's the length and here's the width. Notice this one's a decimal, which we haven't done yet. And the length is 15. Oh, and I'm sorry, I was going to use a color. I'm going to continue without color. We'll see how we do. The length is 15, and the width is 2.5. So those are the two values that I substituted, 15 for L, 2.5 for W. Notice I put it in brackets. That's going to save us a lot of trouble with negative signs later. And then we multiply those two values, and when you do, you're going to get the number 37.5. So the area of a rectangle with length 15 and width 2.5 is 37.5. Okay, let's try another one. There we go. This looks like the part of the formula for Pythagorean theorem, which gives us the square of the hypotenuse by summing the square of the other two sides. So maybe I'll write out the whole formula this time. C squared is going to be equal to, I'll get the color out. Instead of A, I'm going to write the number 3. I'm going to put it in brackets. It's not super necessary this time, but it is helpful. It's also helpful, not just because of negatives, but it's helpful to see what you have substituted by putting it in brackets. Makes it obvious. So there, instead of A, I've written 3, and it will be squared. Instead of B, I've written 4, and it will be squared. That will tell us the value of C squared. I'm working only on this side, though. Down the left-hand side, I'm leaving it alone for now. We'll learn how to do that stuff later. 3 squared is 9. 4 squared is 16. So C squared is equal to 25, and perhaps you can figure out what C must be, if that is to be true. Okay, here I have, let's fill this one in again, this is area of a circle. Here's the radius I've been given it. R is 8.12 over here. Let's substitute that in. I'm going to continue writing A down here. It's not strictly necessary. You can just write equals to and everything down the right-hand side, but it's a good habit to get into to continue writing the A down this side. Pi. Now pi is not a variable, it is always the same value, and I'm going to use the value 3.14. Now that is an approximation for pi, it's not exactly that. So when we do an approximation, we put a little dot, or sometimes a squiggle, over top of our equal sign. So it's a regular equal sign, but it has a dot over it to say, hey, I know that I am not giving you an exact answer now because A is only approximately equal to what you see following here. And I'm going to maintain that dot all the way down now because I know that I'm continuing an approximation. Another option is to stop including A and just including equal signs after this. Then I'll be saying that my approximation, it's understood that my approximation continues. So 3.14 times R, which is 8.12 squared. So there's the squared. Now being really careful here, this is multiplication in between these, and maybe I'll write it in there just to be really clear for now. It's not necessary to have it, but there it is. 8.12 has to be squared first, and then we'll multiply 3.14 by that value. So, and I'm going to continue as I said. That'll be 3.14 times, and the value, I already worked this one out, 65 point, I think I got 9344. That now I can multiply together. A is approximately equal to, I got about 207, I'm going to round off here now, 0.03, about. Okay, so there's the area of that circle. Now this one, this finds for us the, let's put that out of the way, the sum of the first n natural numbers, and n in this case is 10. So if I added up the numbers 1 plus 2 plus 3 plus and so on up to 9 and 10, I will get this value. So let's see what that value will be. Instead of n, I'm going to write the number 10. Let's put it in brackets. Now here I'm going to also have 10 in place of n. I'm going to change my brackets a little bit to make it clear what I've done here. So instead of n, I'm writing the number 10. Now this is a case where honestly I don't know if I would always include the brackets, because now I have lots and lots of brackets that aren't super necessary. Maybe I wouldn't include brackets here, but it's not going to hurt me any. Outside here I've got 10 still, in here, 10 plus 1 is 11. I'm going to change these back to round brackets. You could leave them as square brackets. And that will be divided by 2. 10 times 11 is 110. Divided by 2 is 55. So if I add up those numbers, I should get 55, and you can try that yourself. It works out rather nicely. Okay, let's do a few more. I gave you another formula earlier. Let's try when n equals 4. Let's try this expression. N times n plus 1 times 2n plus 1, all divided by 6. This tells us the sum of the squares. 1 squared plus 2 squared plus 3 squared plus 4 squared, and so on up to n squared for some n. In this case, we're going to have n equals 4, so we're going to cut it off right there. So let's substitute in. Now this time I'm not going to use the brackets in all the cases because I think it's not necessarily helpful here. Here I've got 10, and here I've got 10 plus 1. So see how I've replaced n with 10, n with 10. Now here I've got 2 times n, so I am going to use my brackets because that's my multiplication. I don't want to lose that. And 6. And as you get experienced, you'll see when the brackets are really necessary, and usually it's a good idea, and once in a while it gets too confusing with all of the extras. Here it's really necessary. This is 2 times 10. I got to keep the brackets there to show that implied multiplication. It's called by juxtaposition, by putting these two things next to each other. And so here on the top, I'm just going to simplify my numbers. 10 times what's in the brackets, 11. And then in these brackets, I'm going to do this all at once. 2 times 10 is 20, plus 1 is 21. And that I will divide by 6. I'm sorry, I was filling in 10. I meant to fill in 4, didn't I? Well, I'm going to continue on with the 10 because we are at the 7-minute mark here already. And so let's see. I'm going to do a little cancellation to help myself out. I'm going to divide that by 3 and divide that by 3. Sorry. Dividing 6 by 3 gives me 2. Dividing 21 by 3 gives me 7. I'm also going to divide 10 by 2 to get 5, and this 2 by 2 to get 1. Now I've got 5 times 7 times 11. A little quick math over here. 11 times something is the same as 10 times something plus 1 times something. 5 times 7 is 35. So that's 1 times 5 times 7. And another 350 will be the 10 part. You can add those together to get 385. So if I add up the squares up to 10 squared is what I ended up doing here, that will give me the value 385. Maybe we'll do the 4 version really quickly here. So once again, formula, and substituting in for n the value 4, the correct value 4, and then I've got 4 plus 1, and then I have 2 times 4 plus 1, all divided by 6. That is 4 times 5 times, that'll be 9, all divided by 6. And that's going to give me a value of 30. And you can try that one out for yourself. That'll be the same as 1 plus 4 plus 9 plus 16 is the value 30.